Yo, what's up everybody? It's Brodeur AKA Brilly, and today we're going to talk about the intro to hard surface modeling. And take a look at this example that we're going to just start off with here. And you can see I have two cubes. I have cube A and cube B. Now you might be looking at this and saying, hey, they're the same. But if I were to turn on my grid shading and lines, you'll quickly see that they are different. One of these is actually an organic model. And so when we just start describing the difference between a hard surface and an organic, one of the quickest and easiest ways to discern what that is by understanding what that mesh looks like. So you can actually have the same object and they be two different meshes. And so the ability to be deformed or easily able to be deformed will refer to an organic model. And that is because the mesh is designed so it is subdivided, right? And so if I make a bendeformer, a child of this cube here, you can see that it is easily able to be deformed as opposed to putting a bendeformer on cube A. And you can see that this is not easily able to be deformed. All right, so let's just delete this here and I'm going to add an additional cube into my scene. Now with this intro to hard surface modeling, we're really going to be specifically looking at edge loops. And edge loops are really what's going to give our hard surface model the quality that gives it the characteristics of that object. And so with edge loops, we're going to utilize a lot of modeling, subdivision surface modeling. And so if I were to take this cube here on the right and I were to put it in a subdivision surface, it's going to turn it into a sphere. And that's because it's looking at two or more edges and trying to round between them, and it's doing that on all 6 sides of this cube, therefore turning it into a sphere. But what's going to happen when we start looking and utilizing edge loops is we're going to be able to control and determine the quality or roundness of that edge, the radius of that edge with an edge loop. So let's take this cube A here, and I'm going to hit C on the keyboard and make this an editable object. So we now turn it from a parametric object into a polygonal object. And I'm going to switch over into my modeling mode. However, if you don't, when you go over into point, edge, or polygon mode, now all your correct tools will pop up automatically starting in version 26 and up, I believe. Well, let's just go into model mode anyway. And we have all those tools right here on the left side. And so I'm going to make sure I'm in the edge mode here. This will work actually in polygon or point, but I'll just start in edge mode. And we are going to grab the loop cut path tool, or loop path cut tool. It's really important to get used to these quick commands here. It is nested inside this line cut. Here it is, loop path cut tool. And if the really great thing about Cinema 4D, if you hover over any of these tools, it will tell you, what the quick command is of that. But since we are modeling, think of modeling starts with M. If you hit M on the keyboard, it pops up this little quick command interface. And then if you scroll down to the corresponding number, you can see right there, scroll down with your eyes, not your mouse. If the minute you move your mouse or cursor, that menu disappears. So don't move your mouse, hit the letter M, that pop-up window comes up and I see right there, loop path cut tool is the letter L. So I hit the letter L and just like that, we have our loop path cut. And you'll see here, if I go on any of the edges, it will give me a perpendicular cut. So if I want to make a loop cut around this way, I wouldn't hover over this edge. I need to hover it over this edge so it's perpendicular to that edge that's selected. So we're going to make our first edge loop here. And the thing with sub-D modeling, subdivision surface modeling, is that the closer you create an edge loop to the corner of your object, the sharper that corner is going to be. The further away it is from that corner, the more rounded it's going to be. So I'll make a quick little edge loop. Now let's just for fun throw this into a subdivision surface. You'll see that instead of it just turning into a complete sphere like it did on our cube on the right, now we are starting to define some of the edges. So I'm going to turn this subdivision surface off and let's continue adding some edge loops. So I'll add in another edge loop right here. And we can rotate around it. And now if I turn that subdivision surface on, you can see now I'm starting to define this front corner that we're looking at. Let's turn that off. Let's continue to add our edge loops. And again, depending on how close you are to the edge or how far away you are to the edge will determine the roundness of that edge or the sharpness of that edge. So I'll come in here, I'll add an additional edge loop. And just like that, we've created all edge loops for all areas of our cube. Let's turn that back on. And now you can see we're defining our geometry. Now, a cube is really basic, but it really helps us just talk about the principles of that edge loop. Now, let's look at this cube here on the right side. That is a sphere as it is right now. I'm going to hit C on the keyboard and make this editable as well. And I just want to show you while this is live here, and until you click off this tool, this is still all, procedural. And you'll see as I move this edge loop closer to the edge, it'll create a sharper face. If I move it further away, you see it creates more roundedness, and that'll apply to everything. So if I put edge loops all really far away from the corners, you're going to see that we're going to in fact have a much more rounded cube. And so this is all to your kind of discretion and taste based on whatever it is that you are making. But this is in fact the difference now, just that an edge loop can make. They're built of the same amount of polygons, same amount of edges, same amount of points. Just the edge loop is closer to the corner on the one cube and further away on the other. Okay, now let's jump into something that begins to get a little bit more complicated. So I'm going to add a plane into my scene for this one. I'm going to turn on growth shading and lines as well as turn off my work plane grid, just so it's easier for you to see while you're watching it. And for this, we're going to take a look at the plane itself and the topology. So for this, let's just reduce the number of width segments to 4 and the number of height segments to 4 as well. And let's turn this plane and make it editable. Now you'll notice when we make these objects editable, we do lose all these little procedural tricks and this object tab here. And these are really great and super easy and functional, but now you're gonna be doing all this manually if you wanna change those things, which is good because we're now leading into the process of being able to create whatever type of geometry it is that we want. And so I've got this plane here. And with this plane, I'm going to go into point mode. Now for this, have you ever wanted to create a circular shape out of one of these squared polygons? You'll see this a lot in like sci-fi or tech parts and stuff like that. Think about the speakers on your phone, something like that, that radial grid. Let's try to create something like that. And you can do it in a handful of different ways. In this Intro to Hard Surface Part 1, I'm gonna show you how to do it with the bevel tool. So let's select this first point here. So I'm in point mode, select this first point here on our plane, and let's go into our bevel tool. Now this is a really cool little technique. If I hit apply here, you'll see that it makes this kind of diamond shape or one of these squared polygons rotated on a 45-degree angle. And I'm gonna change my offset to about 60 centimeters. You can put in whatever you want. Just make sure you don't go over the previous geometry. It looks like it's locking. That's because this limit is checked on. If it's not checked on, you can expand up. This limit is pretty darn nice here though. So I'll put this 60 back on here and there we go. Now the next thing we're going to look at is subdivision. And right now it's set to 0, but if you increase this from 0 to 1, you can see that we now get a slightly different shape. And maybe that's a shape that you're trying to get. It's not for this particular demo. But now we're going to go and look at the depth. If I bring the depth from 100 back to 0, you're going to see it gives us the same kind of shape that we had originally started off with, now just with additional subdivisions. But if I bring it from 0 down to negative 100, you can see now we're making a circular shape, which is really cool because we're making a circular shape from within this squared polygon. All right, so now that we got this circular shape here, we've got the size that we want. You might be looking at this. Let me undo that as well. Let me just demonstrate this one more time, right? And I'll just hit apply because this is something that you might also run into. You're like, hey, yes, it is a circular shape, but it's not like a perfect circle. And you might come in here and you might be like, let's add some more subdivisions. You're like, yes, that looks great now. That's a nice circle. That's exactly what I want. This is not what we want. When we're working with hard surface models, we want to try to keep our geometry as low polygon as possible. And so this gets really heavy. And we're going to talk just in a moment about proper topology being quads or tris. And that's our goal here. And in order to make these pieces of geometry, the polygons around this now proper, there's going to be a lot more work to do here. And you'll see in just a second. So let's bring this back down to 1. And let's take a look at our geometry. I'm going to go into our polygon mode here just so I can show you and we can focus in on one polygon and take a look at this. All right, so proper topology is built up of tris or quads when we're modeling. Now there's other things like n-gons, which is what this is right now, but let's talk about a quad. A quad is a polygon that's built up of 4 sides and 4 points. Now if we look at this and count the amount of sides, that's 1, 2, 3, 4, 5, 6. And it's 6 points. It's 6 sides and 6 points. This is not a quad or a tri. And a tri is built up of 3 sides and 3 points. So this right now, this polygon, and this polygon, all the ones surrounding this are not quads and they're not tris. And so this is improper topology. And they're creating what's called open-ended points. So when we're talking about proper edge flow and that gets disrupted and the point doesn't go anywhere, this is going to bring us some issues. So we'll get into the proper topology here in just a moment and correcting this. But before we do this, let's go into our polygon mode. I'm going to select these 4 faces here and I'm going to move this down. A really quick and easy way is you can do it with the live selection tool or the move tool, which quick command is E. Start getting used to those quick commands. And I'm going to hit down either control or command and click and drag this face down. Once I'm doing that, I'm going to hold down shift and that will snap of integers of 5. All right, so we move this face down. Okay, now let's go back to talking about these polygons and how we can correct and fix these since they're not quads or tris. Really, really easy way. I'm going to go into point mode. And in point mode, I'm going to grab the line cut tool, which quick command is M and then K. Line cut. All you have to do, and it will kind of like snap for you to a point as you get near it. It'll highlight it in white. Click one of these points, and I'm going to bring it directly across here and click that second point. You can see that the tether is still kind of formed here. So I'm just going to hit escape on the keyboard, and just like that, we made a cut, and we've turned this 6-sided, 6-point piece of polygon that wasn't a quad or a tri to 2 perfectly even quads. So if you missed that, we're going to do it again. Click this point, then click that point, escape to end that tether, and we're going to do it again. And we're going to do it again. And well, sometimes the line cut doesn't want to do what it does. And I'm not 100% sure why. Sometimes I just literally change the view. So I change my perspective here, and let's try it again. And now it works. So if that's happening to you and you're like, hey, it's just not working, just try rotating a little bit and see if that fixes it, just like it did for me here. All right. Now, if we look down here, technically this is a quad. 1, 2, 3, 4 sides. 1, 2, 3, 4 points. However, you're going to notice that when we start going and creating loop edges here in a moment, that is not going to create the proper loop edge here. So check this out. Before we get in there, let's throw this whole thing into a subdivision surface again. Beautiful, right? This is looking great. And we've got kind of this like little rounded nub here. Nice geometry. But we're not really defining the edges quite yet. And that's because we haven't built in our loop edges. So let's go ahead and do that. So I'm going to go into my edge mode and I'm going to grab my loop path cut tool, quick command, M and L. And let's do some loop cuts here. I'll do a loop cut here, a loop cut here. And now watch this. If I go to do a loop cut here, you see how it's not giving me the proper loop? It is up top, but you can see it's not creating a uniform loop. We'll focus on that in just a second. So let's just create a loop here. And let's instead change the topology down below. Instead of these kind of quads, because edge flow is important. And you can see that we do have this edge that's coming down, and then it just kind of abruptly ends. And so it is wanting to go into this central point. And so we're going to grab our line cut tool again. So M and K. And I'm going to turn, M, come on. M and K. There we go. And I'm going to turn in those into tris. Click one. It's got the tether. Snaps to the next point. Hit escape. And we'll do it again. and one last time. And hit escape. There we go. So now we've turned those into tries. All right, now let's do our loop path cut tool. So ML, and let's see what we've got now. See how it's now giving us a proper loop cut here. So I'll do a loop cut, and now let's throw on our subdivision surface. And you can see that now this is starting to feel kind of like a bump in like a Lego or something like that, right? One of those little nodules. And we're now defining the edges by the edge loop, and it's giving the corner and it's giving this object its proper characteristics. Now, when we did this edge, you can see how, because the distance is different from one point to the next, you can see it's pulling these corner points out a little bit too far. Now, really simple thing that we can do to fix, if I just go in the point mode, my move tool, I can grab all the points that are pointed outwards a bit too far, select them, and then I just can hit my scale tool, T, and I'll just kind of bring those in. Just like that. All right. And now we've got some nice uniform points here. Now, if you've ever seen kind of like a grill or a speaker pattern or something like that, where we've got a lot of these, holes built in, you might look at that kind of a piece of geometry and be like, wow, that seems like it's really hard. But this is when I say, hey, utilize the rest of your knowledge base in Cinema 4D or whatever software you're in to kind of make those steps a little bit quicker. So we're going to do stuff now with the MoGraph module, and let's take a look at our cloner object. And I'm just going to remove this plane from the cloner, and I'm going to drag and drop it, or from the subdivision surface, and drag and drop it into the cloner object. Now let's hop into the cloner, and I'm going to change the size here from 200 to 400 centimeters. So they're perfectly kind of spaced apart here. And I'll say 10 and 6. All right, so we've got this kind of grid now of all of these little pockets. So you wouldn't have to go and do this step, 60 times, right? You could utilize the cloner object and do model 1 and duplicate it across. So let's make this editable, this cloner object. So now you'll see that we have 60 individual planes here that are all separate. So this is not necessarily, I'll go into model mode for a second. This is not what we want still, but let's right click the cloner object and say connect objects and delete. So now let's kind of merge them all into one. Now, when you say connect objects and delete or connect objects or whatever, this is not actually creating like one melted together welded piece of geometry. This is just kind of merging it into just one polygon group here and making it into one what looks to be an object, but they're actually still all 60 individual pieces here. And I can prove that by going into the point mode. And in point mode, if I grab any of the points that we're kind of intersecting here and I go to move it, you can see that they're not actually connected. If you go into polygon mode and you just shift double click, you can see that it's selecting still those 60 individual islands. So they're not actually connected. Now, the way to do this is actually by going into point mode. And while you're modeling, I just recommend doing this constantly, very consistently, almost like, when you click save, also do this, which is optimize. When you're modeling, for no reason sometimes, you just get overlapping points or points that are like pretty much on top of each other. And they're going to give you these kind of issues where you think an object is connected and it's just not. And if you have these kind of issues, you're not going to be able to UV map it. And proper topology is really important when we get to UV mapping, which is what our end goal is here. And that's what we're working towards, really great textures. But before you get really great textures, you have to have really great topology. And so what we're going to do is we're in point mode and we're going to hit Command A or Control A and select all of our points, and we're going to optimize. Now, what optimize does in 3D is it says a point within X amount of distance from another point, I will merge it together. All right, so it's going to clean up our geometry. And the smallest increment of size in Cinema 4D is 0.001. And so that is the distance. If there's another point, if there's 2 points within 0.001 distance or less from another point, it will merge those into one. And these points are directly on top of each other. So the quick command is U, and then you hit the letter O. Otherwise, you go into Mesh, Remove, and Optimize. And if you hit this little gear, you can control the distance, right? You see the default is 0.001, which is what I want. You might have points that you want to be merged together that are further away, in which case you'll have to point in a different tolerance distance. And so I'll hit U and then O, and nothing physically is going to typically change when you do that. So no visible difference. But now check this out. If I move that intersecting point, you can see that these are now connected. This is now one object. If I go into polygon mode and I shift double click on any polygon, it selects the whole thing because this is one mesh now. Awesome. Okay, so again, let's utilize, and I'm going to change this from cloner to grid, something like that. Let's utilize stuff that we already know and understand in Cinema 4D. Let's get a bend deformer here and make the bend deformer a child of the grid. And let's increase the strength. You can see this is not the right direction. If you've ever been fumbling around with the bend deformer and you're like, hey, it doesn't matter which axis I click, it just doesn't do it. Remember, once you click the axis, just hit fit to parent and it will align it. For this, I'm going to do X and say fit to parent. And just like that, you can see that we're bending this, and I'm going to change the strength to 360 degrees so it wraps all the way around. Now, if you missed that first part that we just did, I'm going to repeat some of the steps that we just learned with the optimization, as well as the current state to object or connect objects and delete. So I'm going to right click this grid here, and I'm just going to say connect objects and delete. And what that's going to do is it's going to kind of bake in that bend deformer. Now, once again, these two edges are not actually connected here. This edge that's coming across, you might think it is because visually it looks that way, but if I were to grab one of these edges or a point, you can see that they're not actually connected. But remember, I know that we have points that are overlapping. So I can go into my point mode. I can Control A or Command A, select everything. I can hit U and then O for optimize. And then just like that, the edge is in fact connected. So now this is one piece. Now, if you haven't, done a whole lot of modeling, if I were to show you this from the beginning and say, model this, you might be like, I don't really know where to start. Let's show this into a subdivision surface here. And that way you can see the topology is kind of like very nice here. And we got nice, edge flow and edges and rounding of the corners here and stuff like that. You might not know how to make this, but after going through these pretty basic steps, you're like, that's actually not that hard. All right, so let's say we want to close off the ends of this. How would we go about doing that? Well, we're going to use another tool called the weld tool. So we're in edge mode, which is good. And we're going to grab the loop selection. And I'm going to take this loop selection. And then I'll grab the weld tool, which it looks like this little welder's mask. The quick command is M and then Q, M, Q. And you'll see, you might want to change your angle. I like just clicking off because if you hover around, it might snap to another point on the geometry. But if you just move off the object itself, you can see that it just centers it. And if I click that, you're like, perfect, I made a cap. But look at this. It's not exactly straight. I'll undo that. Not only that, it moves it back a whole loop here. Right? You see that how we lost some of the height now of this. So I'm going to show you a better way of doing this. So what I will do is instead of grabbing this weld tool, I'm going to do the loop path cut tool again. And I'm going to make a loop cut as close to the edge as possible. It doesn't have to be like crazy close or anything like that, but closer to the edge. And then what I'm going to do is that edge is still selected, and the furthest out edge, and you can see next we have this other one. I'm going to then grab the weld tool again, and I will click off, and just like that, it drops back to that closer loop edge that we just put there. And now we've got a perfect flat face to this. So I'll do that again here. I'll just go ahead and grab my loop path cut tool. I'll create a loop cut right here. Then I'll grab my loop selection, grab the outermost edge, grab my weld tool, click, and we've created two really easy end caps. Now, again, loop edges, right? I'm going to be repeating loop edge quite a lot here because that's really going to be controlling the detail of this geometry. And I'll give some loop edges on the front on this face as well as the inside face. You'll need it on both. You flank the corners to control, the quality of the edge that you want it to be. And now just like that, we've got really nice edges all along our geometry. And this is done with some really, really basic techniques. Now, if we look at our growth shading lines for a moment and turn this off, you may be like, there seems to be like a lot of geometry here. This object looks like it can easily be deformed. Yes, that is true. I could throw this in a bend deformer and this could easily be deformed. I think we can actually clean this up a little bit though, because we have some geometry that's not doing anything for the model itself other than giving it more topology. So if I come in here and I grab my loop selection, these horizontal loops that come around in between each circle, I can actually select all those and I can dissolve these. If you hit M on the keyboard, you can see dissolve in here and the letter is N, and just like that you dissolve those additional cuts. Now, we could probably still easily deform this with a bend deformer, but the way we've created it is all with hard surface modeling techniques. And the reason we need these additional rotational segments is because we're working with a cylindrical shape. And that's why it's kind of a little bit heavier as far as the segments go, is because we need these rotational segments in order for it to be a perfect circular shape. But this is still hard surface modeling here. All right, so this is part one of hard surface modeling, but that does not mean that this is the only way to build circular shapes in our model. There's going to be a lot more ways of doing this. And so when we do part two, we'll be able to show more ways of hard surface modeling, but this is a really great beginner's guide to edge loops. And then on the next hard surface modeling demo, we'll start looking at other ways of maybe beveling or modeling in those edges. Hard surface modeling, though, using sub-D modeling and subdivision surface in conjunction with edge loops is just a really powerful way, because then we can get really smooth geometry, but we can turn this down in the editor and have a really lightweight interface with really low polygons, segments, and geometry. And then during render time, we can get that roundness and smoothness back. And additionally, if you have to change or edit any part of the models, you're not dealing with a really heavy mesh that's got a lot of edges, polygons, and points that you have to clean up or move multiple things. We're working with as few polygons as possible.